Hello, ladies and gentlemen. Today we're going to continue with names and formulas, but today we're going to focus on transition metals. We haven't done much work with transition metals, so this actually marks the first time. Now we're going to get an in-depth look at them, and we're going to be working with them for a bit. So the naming rules that you're going to be using for this are the same exact ones from yesterday. So there are no new rules. Okay, there are no new rules. The only little nuance is that now the metal you need to include in the name how many electrons it's giving away. And you'll see what I mean by that right now. So this is a table, a little mini table of some transition metals. I believe that is period 4. Yes, so it is this period right here. Okay, so all the elements here are just all the transition metals in the first row of the D block. Okay, and what this is telling you is the different cations they can form. So let's look at copper. Copper 29. Copper Cu right here can be +1, it can be +2, or it can be +3. Okay, manganese can be +2, 3, 4, 6, or 7. So different transition metals have different options. Okay, and there is no guessing, there's no rules, there's no pattern to it. It's just what we've discovered. So now let's get to the naming. So as you saw, copper has 3 options: +1, +2, +3. If we're doing the +1 option, then you would write copper, and in brackets you would put 1 in Roman numeral form. So 1 in Roman numeral is just 1I. If we're doing the +2 version, copper 2, then you'd have to put 2. Let's look at iron. Iron 3. If we're doing the +3 version of something, you have to put iron 3. If it's +4, you have to use the 4 in the Roman numeral. Okay. So with these transition metals, just know that you have to include in Roman numerals the amount of electrons that it's giving away. If you're wondering about silver and cadmium and why you don't see the Roman numeral associated with it, only reason they have that is because those only have one option. But even though they only have one option, I still want you to include in brackets how many electrons they're giving away. And this applies to anything in the transition world. And let's do an example just so you can see what I mean. So let's say we're combining copper and oxygen. So I'm going to say we have CuXOY. And the reason I'm using the X's and the Y's is because these numbers can change depending on which version of the transition metal we have. Okay, so some of the questions you will be asked will go like this. So you'll be told, okay, here's the formula. Based off of the formula, what's the charge on the transition metal? Let's do one of those. So let's say we have Cu2O. I'm telling you, this is the formula. This is the correct formula. What does the charge on copper have to be? What version of copper do we have? Do we have the +1 version, the +2 version, or the +3 version? Which version do we have and how do we know? So what you do is, since the copper has multiple options, you ignore the copper for now and you look at the non-metal. Oxygen only has one option. Oxygen is always going to be -2. Okay? Oxygen it wants those 2 valence electrons, it's always going to be -2. So for now, we have, how many oxygens do we have? We have 1 oxygen, and that oxygen wants 2 electrons. So if we look at that, from the oxygen, we currently have a charge of -2. Okay, this comes from 1 times -2. 1 oxygen, -2 charge. This is what we have. So now to figure out the charge, we need to somehow cancel this -2. So we need a charge of +2, right? And where is that coming from? It's going to come from the copper. But we have 2 coppers. So what you do is you take the negative charge and you divide it by how many of the metal atoms we have. Oops, that was a mistake. And you subtract it, or you divide it by how many of the metal atoms you have. So in this case, we have a charge of -2. And we have 2 copper atoms. So if you do 2 divided by 2, that's 1. That means from each copper, we get plus 1. So we have 2 plus 1s. 1 plus 1 is 2. 2 minus 2 is 0. The charges cancel, and you end up with a happy compound. Okay? So the charge on this version is going to be plus 1. Okay? So this is the charge on the copper. The charge on the copper is plus 1. Now let's say I change the formula. Instead of Cu2O, we have Cu2O3. This is also correct. I'm telling you, this is the correct formula. If this is the correct formula, what does the charge on the copper have to be? This time we have 2 coppers and we have 3 oxygens. So let's do the same thing we just did. Oxygen is going to be -2. If oxygen is -2 and we have 3 of them, the total charge is -6. If we divide this -6 by how many copper atoms you get 3. That means each copper atom has to be plus 3. 3 plus 3 is 6, and then 6 minus 6 gives you 0. So in this one, for this formula, this has to be positive 3. If we use the plus 2 version, can you guess what the formula is going to be? If we did the plus 2 version, it would just be CuO. Okay, there'd be no numbers there. If we did the plus 2 version of copper, this would just be CuO. Okay, 1 oxygen minus 2, 1 copper plus 2, they cancel and they're happy. Okay, but that's for the transition metals. Now, if I wanted to name it, let me do the 3 we just had. So our 3, I'm going to need more space, so I'm actually going to do it over here. So for copper and oxygen, you have 3 options. You have Cu2O. Cu2O would be the plus 1 copper. Then you have writing with this thing is so hard. Then you have CuO. And CuO would be the plus 2 version. And then you have Cu2O3. Okay. These are your 3 versions for copper and oxygen. The name of this one would be copper. Because the copper is only giving away 1 electron, this would be copper 1. Okay. This would be copper 2. Hopefully you guys are getting the idea. Put 2 I's, Roman numeral. And then the last one would be copper 3. Okay. This part right here is the only new thing. Okay. That is the only thing that's new. The naming rules are the same. There are no new naming rules. It's exactly the same as it was as yesterday. Only difference is now for the transition metals, you just need to include this. So this is copper 1, copper 2, copper 3, and they all end in the same thing. Okay, they're all going to end in oxide. Okay, because it's working with oxygen. Remember, you need to change the N to IDE. All of them are going to end the same. So this is copper 1 oxide, copper 2 oxide, copper 3 oxide. Okay, that is how you name with transition metals. So you just need to put in Roman numerals the charge that is associated with that specific compound. Okay. With these, the lithium, sodium, like these, the ones that are in the groups that follow the rules, you don't need to do that because, these are always going to be plus 2. These are always going to be plus 1. But these aren't always going to be one or the other. Because of that, you need to put in parentheses how many they're giving away so that people know. Because if I just told you, if I just told you you had copper oxide, let's say I said you have copper oxide. Because copper can have three different charges, that name, copper oxide, is not enough for a scientist to know which compound they're working with. Because you have three options. So you have to put the Roman numeral in brackets so that anybody who reads the name knows which option they're working with. That's why you need the brackets. Okay? Because these have multiple charges they can have. And because of that, if you just said copper oxide, it's not enough. And there's just more examples: copper 1, cobalt 2, iron 2, chromium 3, iron 3. So what will be the names of Cu2? Would be copper 2, and this would be manganese 7. Okay, so all you're doing is putting in brackets the Roman numerals that go with the charge. And now let's go to formula writing, which is that these are examples of everything we just went through now. So in this case, we have they're telling us the formula. It's iron 3 oxide. If this wasn't here, okay, this is what I was talking about. If this wasn't there and you just had iron oxide, that's not enough information to write the formula. We need to know what the charge on the iron is. So in this case, it's iron 3, which means the iron is plus 3. And oxygen is minus 2, then we know that. And now we need to figure out how many of each we have. Remember, you have two ways to do it. You have the cross method. Okay, cross method, the 2 goes with the iron, the 3 goes with the oxygen, and you end up with Fe2O3. Or you can do the addition method and just add up the numbers until you get to 0. So in this case, this is minus 2, this is plus 3. So right now, we're at plus 1. If we're at plus 1, we need another oxygen. So if we do it minus 2 puts us at negative 1. And then now we're in negative, so we need more positive, so we add a 3. If we add a 3, now we're at plus 2. And then if we add one more oxygen, now we're at 0. Okay. So you need 3 oxygens in order to cancel out the charge from the iron. Okay. That's an ugly symbol, Fe. Plus 3 is 6. Minus 2 minus 2 minus 2 is negative 6. They add up to 0. Okay. So it is the same rules as yesterday. So I don't want to make this video too long because no one wants to watch 30-minute videos. I understand that completely. I'm trying not to make this too long. But it's the same stuff as yesterday. Tin 4 oxide. Tin is Sn. If you don't believe me, it's here. Where are you? Tin, Sn. I know the symbols do not always match. So this is tin. Okay. So tin is not technically a transition metal. It is a post-transition metal, as they call it. But even though it is a post-transition metal, they are still going to use the Roman numeral because tin does have multiple options. Is it on here? No, they don't have tin on here. Okay, but tin can sometimes have multiple options. Why? As I told you before, as you go down the periodic table, things start to get more and more complex. Okay, so tin has so many orbitals that are available to it that it can have multiple states. So in this case, we have tin 4. Tin 4 means it's plus 4, and you have minus 2. Again, you can do the cross method. If you do the cross method, this is one of those examples where you can reduce. So this is 2, and this is 4. The 2 goes with the 10, the 4 goes with the oxygen. You can reduce that, meaning they can both be divided by a common multiplier. If you divide both of them by 2, then you end up with 1 and 2. Okay, 1 tin, 2 oxygens. Okay, this is an example of reduction. Okay, you can reduce it here. This is an example of reduction. Okay, they reduce it. They divide by the same number. They divide both numbers by 2. If you can do that, if you notice that you can divide by a common number and still get a whole number, remember that no decimals are allowed, then you do it. Okay. If you do the cross method, this is what you get. If you do the addition method, right now we have plus 4 minus 2 gives us positive 2, so we need another oxygen. If we add another oxygen, now we have plus 4 minus 2, which gives you 0, which cancels them out. And you can see you have 2 oxygens and you have 1 tin, which is where the 1 and 2 come from. Okay, you get to the same destination. Okay, that should be it. There are some examples. I'm going to go through the examples from today's sheet. Again, I'm trying to work on making these videos a little shorter, because I know from college, I remember watching 30, 40-minute videos on online stuff, and nobody really wants to do that. Okay, so I'm gonna try to making these videos shorter, just get through the information as seamlessly as possible. Okay, so this is just actually going through the rules that we have been already using. So this is saying in order to get the correct formula, you need the charges to add up to 0, and we already knew that. Okay, we already do that. They're just giving it to you in formula form. So this is total cation charge. So the charge of a cation times the number of cations. So in this case, with the iron 3, you have a plus 3 charge and you have 2 of them. So this is plus 6. This is, you have a minus 2 charge and you have 3 of them. So that's minus 6. That's all this is saying. So this is just they're putting in formula form everything you've already been doing. Okay, that's all these slides are. Some understanding. Okay. So in the case of FeCl3, let's use their version as an example. In the case of FeCl3, we make the following substitutions. They're just telling you what they plug in. So they're trying to figure out what the charge on the iron is. I told you these are some of the problems you're going to get. So iron can have multiple options, but based off of what you see, which option does it have to be? Chlorine, we'll work through it. Chlorine has to have what charge? Charge of the anion is -1. How many of the anions do we have? We have 3 of them. So what's the current charge right now? Current charge is -3. Okay. How many of the cations do we have? We only have 1 iron. What does this number have to be in order for this to equal 0? It has to be 3. Positive 3. 3 times 1 is 3, and then 3 minus 3 is 0. Okay? So this is just showing you how to do it in a mathematical way, even though we've already been doing it this way. But this is they're just explaining it to you for clarity. But this is exactly what we've been doing. Let's see, are there any other examples? The name of this would be iron 3 chloride, because the charge on the iron is +3. Okay, that's what this is. Iron 3 chloride. Are there any other examples? Let's see here that are good we can do before we get into the sheet. Yeah. Okay. So I think that's it for the information. Let's do 2 of these examples. It says the correct name for this compound is vanadium 2 oxide. Is this true? So what's the charge on the oxygen? Let's use the formula they just showed us. Charge in the oxygen is -2, and you have 3 of them. And you have 3 of them. Okay. The charge on the vanadium. The charge on the vanadium, they're telling us is 2. So the charge on the vanadium is 2. And how many of those do we have? We have 2 of them. 2 times 2 is 4. -2 times 3 is -6. These numbers do not cancel. So because they do not cancel, this is false. This should not be vanadium 2. This should be vanadium 3. If it was 3, then it would cancel, because 3 times 2 would be 6, and then 6 minus 6 would be 0. So the answer to this is false. Okay? It is false. If it was 2, you don't have enough to cancel out the oxygen. And then the correct name for Cu3N is what? Okay, where is N on the periodic table? It's in group 15, it has 5 valence electrons, so it is going to have what charge? Going to have a -3 charge. And how many of those do we have? We have 1 nitrogen. So what is the charge from the nitrogen? -3. Copper. How many of those do we have? We have 3 coppers. If we have 3 coppers, what does X have to be in order to cancel out this number? Okay, this is we need to cancel that -3. X needs to be 1. So if X is 1, that means the copper has a +1 charge. And if it has a +1 charge, then it would be copper 1. Okay? It is copper 1 nitride. Okay? 2 and 3 are too many charges. And A is wrong because I told you if you don't give me the brackets, if you don't tell me how many it's giving away, then you can't know what the formula is because copper can have multiple charges. All right. That's it for the slides. I'm going to spend some time going through some of the practice problems. So for this section, you should be working on predicting and naming with transition metals. This is the section you're working with. Okay, and let's do 2 of these. Let's do 26 from the classwork. What is the formula of the compound that occurs when titanium 4 and sulfur combine? So titanium 4. Titanium, let's first figure out what is the symbol for titanium, if I remember. Titanium is Ti. So we have Ti plus 4. This is what we have. We have Ti plus 4. Where is sulfur on the periodic table? Sulfur is in the same group as oxygen, so sulfur would be -2. So we have S -2. If you do the cross method, you get, I'm going to write it down here because we don't have a space. If you do the cross method, you get Ti2S4. This can be reduced, and it can be reduced to TiS2. Okay. So remember, if you're going to do the cross method, you just have to remember to reduce if possible. If you do the addition method, right now you have a +4 charge and a -2 charge. If you add them up, you get +2. So we're still in the positive region, so we need to add another sulfur. If we add another sulfur, then you have +4 -2 -2. That equals 0. They cancel out. You have 1 titanium and you have 2 sulfurs, and that'll also give you TiS2. And that's 26. Let's do one more of those, and then let's go to a naming one. Let's do zinc and oxygen. So it says, what is the formula that occurs when zinc and oxygen combine ionically? If you notice, for zinc, there is no Roman numeral. And the reason there is no Roman numeral, even though I would like there to be, they really should do that. Zinc can only have one option, and that option is +2. So zinc is +2. Okay. So for this question, what we have is Zn +2, and then you know that oxygen is always going to be -2. So you have a +2, you have a -2. They already add up to 0. So they cancel out, and you have your formula. So the correct answer in this case would just be ZNO. That's the answer for 29, just ZNO. Okay, that one didn't have a charge or a bracket, so let's do one that does. So 28, iron 3 chlorine. That's what we're adding iron 3 and chlorine together. That's what we're combining. So if we have iron 3, the 3 tells me the charge. This is Fe plus 3. Chlorine is a halogen. All the halogens are going to be -1. If you do the cross method, you get 1 on the iron and you get 3 on the chlorine. If you do the cross method, and you end up with FeCl3. And I believe that one was also in the slides. If you do the addition method, right now you have 3 times X plus -1 times Y. The X's and the Y's are just so the X is how many irons we have. The Y is how many chlorines we have. Okay, I'm just following the formula the way they have it set up in the slides. But you've already been doing this mentally, so this is not new. So if you set it up like this, let's start off with 1. I always start off with 1 and I increase it little by little. So if let's say we have 1 iron. If we have 1 iron, then we have +3. So in order to cancel that, this needs to be 3. Okay, this one's simpler. You do that, they add up to 0 and they cancel. You end up with 1 iron and 3 chlorines, which will give you FeCl3. Okay, now let's do one more example where we're naming the formula. Let's do one of these down here. AUN. AUN. So if we're working with AUN, we have 1 of each. Because we have 1 of each, that makes life easy. Nitrogen has what charge? Nitrogen has 5 valence electrons. So if it has 5 valence electrons, that means it has to be -3. And if nitrogen is -3, we only have 1 of these. If we only have 1 of these, it has to be +3. It has to be +3 if we only have 1 of them. So now that we know it's +3, we can write the full name. Au is gold. Au is gold. So what is the name for number 39? This would be gold 3 nitride. Gold 3 nitride would be the name of this one. And I'll do one more. Gold 3 nitride. Let's do Sc2S3. Sc is scandium and S is sulfur. So if you have S3, S3 means that we have a -6 coming from the sulfur. Let me write it out. So you have the X from the cation. So this is the charge. This is the charge of the metal. We don't know what that charge is yet. We're trying to figure that out. And you have 2 of them. Plus, you know the charge on sulfur. The charge on the sulfur is -2. And you have 3 of them. So this comes out to be, this is -6. So this is -6. What does X have to be to cancel it? X has to be 3. So we know that the charge on the Sc is +3. And now that we know it's +3, we can write out the full name. Okay. Sc is scandium. So let me make sure I spell that right. So for number 38, 38 would be, I'm going to write it here for the sake of space. 33 would be scandium 3 sulfide. Okay. And that's it for the examples for the transition metals. Oh, now it's okay. The numbers are stuck at the top. That's interesting. Okay. So that's it for the examples. Again, the rules are the same as the ones from yesterday. Okay, so the day 3 work, and you're going to be doing stuff very similar to that. Okay, it's the same naming rules. The only thing is with the transition metals, now you have to add the number of electrons in that bracket form. That is the only new part. Okay, that is the only new part. All right. So if you guys have any questions, again, always feel free to ask. And I wish you the best. And this video did get to 30 minutes. My apologies. I'm going to work on making these videos shorter so that they're easier to just digest. All right, take care.